Our next speaker is Yiannis Mavrommatis. I think I just about got that right, Yiannis. I've known Yiannis since I started at St Mary's as head of Shaz, but I found out a couple of things about him this afternoon that really made me realise why it was never a good idea to cross swords with him. Yiannis used to be, wait for it, a Special Forces paratrooper. He has a kickboxing black belt and is a former cage fighter. So next time you meet Yiannis, don't upset him. There's hidden talents there that many of us were not aware of. I'll move the slide on for Yiannis. That's the title of his talk. I won't read it out to you. I'll hand over to Yiannis now, 8 minutes, and again, I'm sure you'll all enjoy what he has to say. Yiannis, over to you.
Thank you very much, John. Good afternoon, everyone. My name is Yiannis. Whatever John said was 20 years ago or 10 years ago. I can't do anything now. So what I'll try to do today is to show you why genetics or genomics has not only infiltrated medicine and nutrition, but is actually trying to take over the entire field. Before we start, molecular biology lecture. This is how our DNA looks like, and all it is basically two ribbons, those gray structures that you can see here, that are held together with 4 different types of magnets. We're too lazy to call them by their name, so we just use the first letter. We have magnet T, C, A, and G. That's all it is. 2 ribbons, 4 magnets. The beauty behind the molecule is the simplicity. It's just very long. So the DNA from one person, if we manage to stretch it, it will go from here to the moon and back 6,000 times. Yeah? So it's quite long. Keep that in mind. We have the same DNA with the chimpanzee by 98%. And within humans, we share 99% of our DNA, 99.9% of our DNA. So in this room, we all have the same DNA by 99.9. And if that's not impressive enough, I have another way to make this point. I don't know if any of you know who this lady is. Her name is Margot Robbie. She is arguably one of the sexiest women on the planet. Not me, that was voted objectively. So obviously we're talking about a very pretty human. Be nice, yeah? I share 99.9% of my DNA with Margot. If she knew, she would kill herself. And the beauty behind it is that we cannot even predict how DNA combination takes place. So if Margot and I had a baby, I would have said no, by the way, but if we did have a baby, it's not 50-50. If it was 50-50, it would look like this. Luckily, that doesn't happen. So now that I use this gimmick to grab your attention, if we look so different on the outside, how naive do we have to be to assume that we look exactly the same on the inside? Why, if I eat an apple and you eat an apple, that apple will be metabolized in exactly the same way? It won't. All different. The main differences are differences on single magnets. So it can be that one magnet in that whole sequence here to the moon, back 6,000 times, one magnet may be the difference between me having type 1 diabetes and you being healthy. You being healthy and me having celiac disease. It can be the difference between Angelina Jolie having both her breasts or having to undergo double mastectomy because she gets cancer. It was one letter difference that she had in her DNA, one magnet. So obviously we need to consider that when we devise our plans, our treatment, our prevention schemes, because we are not the same. With regards to nutrition, we still have the 2 disciplines. We have nutrition and genetics, but we have 2 directions. So we have the effects of nutrition on the DNA and the opposite. The direction from our diet to DNA is nutrigenomics. The way DNA dictates how we metabolize different nutrients is nutrigenetics. You will be hearing these terms quite a lot from now on in the media, so it's a good idea to know what they mean. I don't want to get too sciencey, just one example from nutrition, and I will explain what it shows. What we have here is the risk to suffer a heart attack, basically. depending on how much coffee you drink. And we know from studies that if you exclude genetics, there's no effect. We don't find anything. It doesn't matter how much coffee you drink, your risk to have a heart attack does not change. If you do include genetics, however, it looks a bit different. So if I have an A magnet in a specific position in my DNA, it doesn't matter how much coffee I consume. 0 cups, 1 cup, 2 to 3, 4 or more. The risk doesn't change. The fluctuation that you see here is normal variation. It's not even significant. If, however, instead of an A magnet, I have a C magnet or 2 C magnets, then my risk to have a heart attack increases the same in proportion to my coffee consumption. That means that if I know that my DNA looks like this, I need to be careful with how much coffee I drink. At the moment, we don't utilize that information. So why is genomics everywhere? It's all about money. It is, sadly. But back in 2001, to genotype one individual, it cost $100 million. Now, it's less than $1,000. This is the projection, how people believed back then that the price would drop with time. And science beat that projection quite substantially. So back in 2001, you needed to have walk-in computer rooms to analyze one person's DNA. Now, you have this USB stick. I have one in my bag if you want to see it. We have 5 at St. Mary's. And we're not even doing sequencing, just to show you how applied this is. In a few years, you will all have your DNA report in your hands. I don't know if you have heard about this company, 23andMe. It's the biggest genotyping company. They send you a tube, you spit in it, you send it back, and they send you your DNA report back. But we also have this company, DNA Fit. They won the best company in the UK just last year, the Queen's Award, and it's still one of the biggest genotyping companies. But we also have this one, and this one, and this one, and you get the point, yeah? So there are so many that we actually have a website comparison facility, like the Meerkat kind of thing, but without the meerkats. It's actually easier to find a genotyping company than a registered nutritionist, just to show you how big it is. So it's just a matter of time until every single one of you has your DNA in a memory stick or in your computer. How popular are these kits? These are the number of kits that these companies have sold. And you can see that it goes from absolutely nothing 5 years ago to more than 15 million kits now. And this is a huge underestimation because it only includes the major companies. It doesn't include the large number of smaller companies. So everybody is having their DNA genotyped. And if you don't believe me, the man himself, Secretary for Health, Matt Hancock, just last week tweeted that genomics is the future, it's bigger than Brexit, and Britain leads the world. I mean, besides the desperation to bring Brexit to it, I have to say that I agree with every single statement of those 3 statements, and luckily, all scientists agree as well. Thank you very much for your attention.
I always thought Yiannis was my brother from another mother, and now I know that really is the case after that talk. Yeah. Thank you, Yiannis. Excellent, very good.